Step 1. A commercially available diamond substrate is used as a starting material for ultrapure, isotopically enriched CVD growth. In a plasma consisting of hydrogen and methane, diamond is grown layer by layer on top of the substrate. This crucial process allows us to tune the isotope composition of the overgrown diamond layer. The tailored, isotopically purified diamond is implanted with high-energy nitrogen ions. On their way into the diamond, they create vacancies before coming to rest at the desired depth. High-temperature annealing is used to rebuild the damaged diamond crystal by mobilizing the vacancies and eventually creating NV or other color centers as well. In a final quality check, the NV diamonds are characterized using quantum optical laser microscopes where a green laser is focused on the diamond and the NV centers. It also collects their red fluorescence, and using microwaves fed through a resonator structure on the diamond, the quantum state of the NV center can be controlled, and key properties such as density, position, and coherence time can be determined.